In this video, we're going to be talking about conditional probability. Sometimes the knowledge that one event has occurred changes our assessment of the likelihood that another event will occur. Consider the following example. Suppose that 0.1% of all of the individuals in a population have a certain disease. The presence of the disease is not discernible from appearances, but there is a screening test for the disease. So we're going to let D equal the event that a person has the disease. So the probability of D is 0.001. Now, suppose that 0.1% of all of the individuals in a population have a certain disease, right? We're still moving on with this example. Well, 80% of those with positive test results actually have the disease, but 20% of those with positive test results actually do not have the disease, meaning they got a false positive. So we're going to let P equal the event that a person tests positive for the disease. Knowing that event P, the person tested positive, has occurred, changes the probability of event D, the person having the disease, from 0.001 to 0.80. So here we have the probability that a given person has the disease given the person tests positive. That's what that line means. So the probability that a person has a disease given that the person tests positive. And that's going to equal 0.80. This is an example of conditional probability. Conditional probability is a probability that takes into account a given condition has occurred. So the equation that we use for that is the probability of B given A equals the probability of A intersected with B divided by the probability of A, meaning the probability of A and B divided by the probability of A. Let's go a little further here. So the article "Chances Are You Know Someone with a Tattoo and He's Not a Sailor" from the Associated Press of June 11th of 2006 has included the results from a survey of adults aged 18 to 50. So the accompanying data are consistent with summary values given in the article. Take a look at this set of data. Assuming these data points are representative of the adult Americans and that an adult is selected at random, we're going to use the given information to estimate the following probabilities. So we want to know, what is the probability that a randomly selected adult has a tattoo? So what we're looking for is the probability of a tattoo. So here we can see that we have 24 out of 100, meaning 0.24. Well, what is the probability that a randomly selected adult has a tattoo if they are between 18 and 29 years old? This is a condition, meaning we're looking for the probability of a tattoo given that the age is between 18 and 29. So here we're looking specifically for that number 50. How many adults in the sample are ages 18 to 29 and have a tattoo? 18. So we're able to say that 18 out of 50, which is a 0.36 chance. So what is the probability that a randomly selected adult is between 18 and 29 years old if they have a tattoo? Notice here, we've switched it. We have another condition, and the condition is that they have a tattoo. So we're looking for the probability that a person between the age of 18 to 29, given that they have a tattoo. So what we want to know is how many adults in the sample have a tattoo. There's 24, so that's going to be our total amount. And how many adults in the sample are ages 18 to 29 and have a tattoo? And that's 18. And so here we're going to have 18 out of 24 people, which comes out to 0.75. So it's important to make sure that you know what you're looking for when you're dealing with conditional probabilities.